free training provided by the HVAC School podcast is made possible because of the generous support from our sponsors, Testo, Rector Seal, and Carrier. All right, if you guys have listened to this podcast for any amount of time, you know that I kind of have a little bit of a crush on the Testo 605i. It's just a stupendous. Can I say stupendous and not have it seem like hyperbole? I'm going to choose to say stupendous. It is a stupendous tool for the investment that you spend on it. It is a great thermal hygrometer. And for those of you who are like, what the heck is a thermal hygrometer? Well, let me tell you. A thermal hygrometer is basically a digital psychrometer. That's another term for it. And it measures wet bulb, dry bulb, relative humidity. Dew point, it can extract all of those. If you've ever looked at a psych chart, you need a couple pieces of information, then you can extract the rest. But what the 605i does really well is that you can measure these readings in Duct. So you can take wet bulb, dry bulb, relative humidity in the return, wet bulb, dry bulb, relative humidity in the supply, and right there in the Smart Probes app, it will actually calculate delivered capacity as long as you enter the CFMs, which is pretty cool. CFM. I always want to say CFMs, CFM of air. So the 605i is a great tool, but when you add in what Jim Bergman is doing with the MeasureQuick app, which you can find out more by going to measurequick.com/download now on that application. I'm excited about that product. But the Testo Smart Probes and the Testo 605i work with Jim Bergman's MeasureQuick app. And so you can get the best of both worlds, a really, really highly functional app plus the Testo 605i. The actual Smart Probe app that you can use directly with the 605i, it works great, but you can extend its functionality by using it with the MeasureQuick app. And so getting delivered capacity is a huge thing. I mean, you can actually show your customer right there on your phone. We've already done this on many occasions. Like, look, this is how much capacity this system is actually delivering. Here's what you paid for. Here's what you got. It's a great product, and it's also just a great way to get your indoor wet bulb and dry bulb, which you need anyway if you're going to calculate superheat on a fixed orifice system. If you want to use it to calculate target delta T, air temperature split, it's also great for that. It's just a good all-around temperature measurement device, plus it gives you that additional data that you can only get from a thermohygrometer, and you have the ability to get it in the Duct. Plus, it's Bluetooth. And like I've mentioned a million times, you can get that particular product, the Testo 605i, by going to TrueTechTools.com. And at checkout, use the offer code GETSCHOOLED, all one word, no caps, no spaces, GETSCHOOLED. Look at the bottom left-hand side of the screen when you're in the process of checking out there, and there's a coupon code box. And you type GETSCHOOLED in there, and you will get a great discount.
Meet Zoomlock, the 10-second flame-free refrigerant fitting from Parker. Reduce labor costs by 60% with no brazing, no flame, and no fire spotter. Discover how Zoomlock can help you be more efficient and productive. Visit Zoomlock.com for more information.
Seriously, his initials are B.O. for a reason. Brian Orr.
Hey, this is the HVAC School Podcast, and I am Brian, and this is the podcast that you listen to when you want to remember some things that you might have forgotten, and maybe also remember some things that you forgot to know in the first place. Today's episode is something that you probably don't practice. I'm going to bet that out of those of you who are listening, there might be a literal handful. I can hold you all in one hand. So all Lilliputians, all little people out there who have actually practiced this. Because it's a very cutting-edge thing. It's something that we're starting to hear more about. Some states you may have it, but usually it's a different industry that does this, and it is testing the envelope of the house. And so that's using a blower door. And before you check out on me, Joe describes this in just a very good way. Like, he talks about it in a way that I think makes sense to the AC technician. So I've got Joe Medosch, who's going to be talking to us about the duct in the home that we consider the least, but we really need to consider it more. So I got Joe here, and Joe is like the expert at all things blower door and lots of other stuff. But we're thinking a lot about blower doors right now. A lot of blower door talk going on. Introduce yourself. What do you do? Who are you? Just the basics.
Yeah, I'm Joe Medosch, and I own Energy Environmental Consulting, and I also am the executive director of Healthy Home Environment Association. One of my things I regularly preach about is about why HVAC contractors don't include the envelope as one of their things that they actually evaluate. So we were here to talk about where's the benefits and challenges that go along with that.
Got it. So you just jumped right in there, and we're going to town. So the duct that we don't consider is the envelope of the house. That's the title of the podcast, the duct we don't consider, and the duct we don't consider is the envelope of the house.
The largest duct system in the house is your envelope.
Let's talk about that from the get-go. So what are some things that aren't being considered that ought to be considered as it relates to the envelope?
Most HVAC contractors who do a great job, they're designing their system. They use a manual J, manual S, manual D, all these things to tell you how much flow do I need, where it is, what's the impact on the R value, the windows, orientation, all that great stuff. But one feature that's in your software that nobody uses is the infiltration rate that's actually in the house and is always estimated. And there's no way to really estimate it correctly unless you actually measure it for a variety of things. So if you're just guessing, you're definitely just making stuff up.
So there's other considerations, and I was actually having a conversation with one of my sales staff just 4 days ago when we were talking about so much of manual J is estimation, and this is a huge one. But then there's also things even like insulation where you don't always know what it is. And when you kind of compound all these different things that you're guesstimating, then you can come up with a pretty dramatically incorrect answer. And have you seen cases like that where there's a pretty incorrect answer and it's due to infiltration that's not being accounted for?
Yeah, but if you look at your manual J in terms of what infiltration is, it could easily be 15, 20%, but I've seen it be on existing homes as much as 40 to 60% of your system's requirements or how much BTUs you need is on infiltration. And it's just shocking that people just accept that. And that's actually if they measure it. Even if you guesstimate how leaky the house is, you could still be 40% of your load is infiltration, something that we can actually correct or make improvements on. It isn't just comes with the house. I'm not going to change your insulation. That's really a rare thing. You may add more in the attic, but I'm not going to change your walls. It's never beneficial for energy-wise to replace your windows or anything like that. So it's just not a great bonus in terms of energy reduction. But you can get major energy and comfort out of actually sealing up the envelope.
What you just said sounded like heresy to me, where you said that you're not going to get any energy benefit out of replacing your windows. You mean that the payoff's not going to be there, or you literally aren't going to benefit?
Neither one. You're not going to benefit. So the only benefits you get are actually from the street value, the sidewalk upgrades that you put in new windows. There's an enormous amount of research that's been put into changing your windows, which are not a high R value anyway. Even your solar gain stuff is minor. Depends on what climate zone you live in. But the actual benefits of energy reduction from windows usually has about a 40-year payback. You can get a lot of great payback by adding sunshades or sunscreens or something like that. Those have huge quick paybacks. But changing your windows out for energy savings has been proved to be a false claim. It doesn't really actually happen.
So what we're really doing with a window in most cases is we're decreasing the amount of solar radiation that comes through, so the amount of radiant heat that travels through the window in the best of circumstances. But when you're in like a high latent environment like we are, and a lot of states in the South are, and even other parts around the country, that radiant gain doesn't add to your latent load. It's directly radiating through the space, which means it's increasing your sensible temperature without affecting your latent, which in some cases isn't a bad thing. And for example, in my house, I would probably do well to leave all the blinds open and leave everything so that as much sun could stream in, so that way it gives you some radiant load, which drives up your sensible temperature, which helps the system run in order to dehumidify. So there's actually some cases in which you may want some of those radiant gains.
Yeah, and most homeowners aren't getting that or understand how that is. In fact, the last thing that they think they want is to have a major solar gain on their house or their furniture and other stuff that then makes them feel hot. So again, it may change your humidity factor and how they feel comfortable, but most people don't sense it that way. So most people aren't really that concerned about whether there's too much sun shining or not. But back to the original point, is swapping out windows, paying a lot of money for changing out your windows. Cheaply, you could do it for maybe under 20 grand, but most people are spending more. It's actually buying a car with a long-term loan, and that's usually how they kind of sell it, that you're never going to make that payment back in terms of energy savings. And maybe some comfort, yes, but not energy savings.
So if that doesn't work, let's think about what does work and what is some of the best payoffs. So you're talking about the envelope. Let's start with, if we want to plug into a manual J an accurate infiltration number, which I guess we're almost saying that we don't want to plug in a high number. We want to fix the number before we plug it in to manual J. So if you have a house that has high infiltration rates, fix that space, that shell, so that way you're not having that leakage into the space, and then plug it into manual J.
But just so we're on the same page, so that we do these nice systems, they're clean, beautiful installs, you got great supply. Let's say we overcome the undersized return, we've got a good supply and return. What controls all of this? It actually has to go somewhere in the house, stay contained, not get influenced or degraded by the infiltration factor. So my example was, imagine that if somebody called you up and said, we're really uncomfortable in the upstairs, and you found out that they never close their windows. Their windows are always open. So they're like, oh, we're so hot in the summer, we're so cold in the winter. And I'm like, well, you should close your windows. And the reality is you should seal up your envelope, because these are major issues, especially in a hot, humid climate where your attics get, people are like, well, let's just say it's 100 degrees outside. Your attic is 140 degrees. So that air leakage is coming in. So people who have a 2-story house, they realize their upstairs is always hotter, and it's because of infiltration. And that's a major thing that is correctable. So in fact, you do a manual J and you only get these 5 choices: tight, semi-tight, average, semi-loose, loose. That doesn't really quantify. In fact, if you really have an older house and you just picked loose, you're probably only half of how leaky the house is.
Well, there's that, and then there's also the fact that getting the manual J right so that you correctly size the equipment, you want to do that once you fixed the duct that's leaky. And so in this case, the leakiest duct is the house itself. So fix the leaky house and then test it so that way what you're plugging into your manual J is actually a good number as opposed to a bad number.
Or realize that you should be at least sizing the equipment correctly. So you now realize that the 3-ton out is not a 3-ton in anymore, because I know how leaky the envelope is and how much infiltration impacts this system amount. Now I need to go to a 4-ton, which it didn't need. But some people would rather do that and go, I sized it correctly, than actually fix the problem.
All right, so now let's go into, I guess the first step is to test the conditions that you find when you arrive. So how do you do that?
So the blower door is a simple concept. It's just a large calibrated fan with a gauge. So you seal up the house in some people call wintertime conditions or closed house conditions. All of the outside windows are closed. All the inside doors and closets, all that stuff is opened up. So I basically have isolated inside to outside. And now I run the blower door. And the blower door is a very powerful device that will measure the amount of pressure inside of it and determine for you, all back to the same concept, how many CFM is this house leaking? So based on the volume of the house is how we kind of do it as just a process. The volume tells me how many air changes per hour I have in this house. So it tells me how many times the air is circulating while the blower door is on. And we can compare everybody's house. It's just a common reference to do that.
That's 50 pascals, negative?
Yeah, thank you. Yeah. When we depressurize, it's negative 50. So I have negative 50 pascals, and I can say, I have this many CFM divided by the volume times 60 gives me an actual air changes per hour.
So, and because I was talking to you about this a couple of days ago, when I first heard about it, I'm like, oh man, how do you calculate the cubic feet of air inside of a house easily? But then you told me that it really isn't as complex as I wanted to make it.
Most homes may have 1 or 2 ceiling heights, and if there's no vaulted ceiling, it's pretty straightforward that I can just go in and be like, well, most of it's all 8 feet or it's all 9 feet, except for these one areas. And I can do a square footage times 8 foot plus the master bedroom is this much with an additional foot on top of it. So cathedral ceilings or whatever, you just kind of create a process. And the best thing you can get is a really good laser measuring device. Bosch makes one, Disto makes one. They're a little expensive, but for $200 you can get something that actually calculates the volume as you go. And technically, if you want to follow the NANSI standards, they actually recommend you're measuring the outside of the house, which can make it easier. Sometimes the garage can be a challenge, but you actually can measure the outside house, because that's actually where the air barrier is, or that's where the envelope ends, is technically the outside of the house. So that's actually a standard. You can measure inside, is fine, but the more volume you get, the better air changes per hour you end up with.
But if you measure the outside of the house and then you just subtract the garage, then that gives you your...
Yeah, that's right.
Garage or attics. I mean, obviously, if you have an attic.
And adjust the volume inside. So there's multiple ways to measure it, but the point is you are just trying to give it a measurement and confirm that I'm within a plus or minus that gives me reasonable results that I could live by.
Right, and it's just not the point I was wanting to make. When I was initially thinking, I'm thinking, okay, I literally have to go into every single room, measure every single room, every single closet, but it's not necessarily that difficult.
No, right.
So the process is blower door depressurizes the house down to 50 pascals, and then it's measuring the CFM leaving the house. You then calculate that with the square footage of the house, cubic feet of indoor space in the house, and then that tells you what your air changes are per hour, correct?
That's right. So while the blower door is running, in order to get any kind of measurement, there must be leaks, and all homes leak. And I can easily, while the blower is running, go around and find this leakage in the house. A lot of times you can just find it with your hand. You can actually feel air blowing out of your switches, your receptacles, and all these kind of conditions. So that's not the problem. The problem is, where is that actual switches in that junction box connected to the outside? Usually it's the attic, or if there's a crawl space, the crawl space are combined. But your goal is to then make assessments as to, okay, I need to go find where it leaked. Don't put the gasket over the receptacles, because if somebody cut their arm off and you put a couple Band-Aids on it isn't the solution. You need to go to the source and correct it, which is somewhere where the envelope begins, either above or below that. Usually it's the attic that's got a big hole for a small little wire. All those need to get sealed. Your drywall doesn't actually contact all the wood, so it leaves these little gaps that all add up to large infiltration that happens and creates pressures and allows hot air. Hot air, you guys are pretty savvy with your understanding of science on how it works with air conditioners. Hot goes to cold. That means that my hot attic air always wants to come down literally into the walls and into these areas and shows up in these areas, clearly impacting comfort.
Yeah, and that's an important consideration because some people will think, why would your house be negatively pressurized? When you are conditioning a space, you are creating a negative energy environment. You're creating an environment in which you have a driver, and that driver is all this hot, moist air wants to make its way into this cool, lower relative humidity space that you've created. And in that case, we're talking about the cooling season. But regardless, you don't want to have situations in which either energy is escaping your home or entering your home, and you're always going to have that driver no matter what you do. All right, so you mentioned a couple of the common things that you seal at that point, but how do you find them? You mentioned you can do it with your hand, but what are some of the other ways that you can find the spots that are leaking in?
Again, we'll go back to the blower door's active. It's running. You can hear it in the background. It's at 50 pascals, and I can now separate my gauge from the original location at the blower door. And now there's these devices that all manufacturers sell, or you can make your own. It's called a pressure pan, and what it does is it measures the pressures with the gauge. So I know Steve Reardon. He's actually got some nice videos out there that are showing how this process works. So I now have these pressures that are moving in. So if I've got 50 pascals coming into the house, and I can now measure all these locations where that is. So you can put your pressure pan around the receptacles or over a can light or even over the duct system and measure these pressures. So a rule of thumb is anything that's connected to the interior part, which means switches, receptacles, even your exhaust fans, anything above 5 pascals plus or minus is connected outside. If it's above 10, you probably need to figure it out and solve it. If you're closer to 50, you're outside. All right, that's the concept. So the closer I am to 50, I'm outside. Duct test is a little more tweaked. So if you put your same pressure pan over your duct system, which again, anywhere where you cut the drywall, which is your most common air barrier, then that becomes your air barrier. Imagine that the duct system, I cut a hole, I put a grill in, and I got my duct in there. And now as it moves up into the attic, it's the air barrier. So if there's a big hole in the duct system, clearly I get air coming in directly from that part of the duct, and I can measure that and determine that there's leakage in my duct with the blower door. So the pressure pan has good analysis of leakage that are connected outside with holes in the attic, holes in the crawl space, but also holes in your ductwork. It's a very simple device to do this. The rule of thumb for duct testing is if it's above 2 pascals, then you really need to look into this. If it's above 3 to 5, you got issues. If it's above 7 or 8, you got significant leakage in that run, and it is specific to that run. So it doesn't mean I got leakage anywhere like a duct tester does. It says, oh, I put my pressure pan on this one supply in this one bedroom. I know that if it's measuring 8 pascals, I know it's between this boot and the main trunk. Somewhere is the leakage, and it's very identifiable, and I can actually locate this. It's a great tool for locating duct leakage.
Very interesting. So it is different, though. So it's good for finding kind of a general view of do you have duct leakage, and then it gives you sort of a pinpoint specific, and it's more a proximity. It's not going to give you necessarily exactly, but it's going to give you a good idea of what general area.
Yeah, I know that it must be near that trunk and somewhere between that trunk and that boot. You don't need to go roaming all over or looking at other trunks. It's in that section is where this leak must be, or it's near that trunk where that takeoff is.
So doing it with the pressure pan, though, and the blower door, it's not like a duct leakage tester that's specific to duct leakage, because it's not going to spit out a number and tell you this is exactly how much your ducts are leaking, but it is going to give you a good general idea of what's going on.
Think of it as a semi-quantitative test. So it does give me a number, so I do get something, so I'm not just guessing that I have pressure. I don't know what it means, so I do have a number, but it's not a quantitative in terms of how much CFM I'm leaking. So your duct tester says you're leaking this much CFM, but you're leaking anywhere and everywhere. The pressure pan says, oh, you're leaking in this area. I don't know how much, but it's significant enough to check. So somebody who does do both, if you're going to do a blower door test, you get the blower door on, you go around and check all your ducts, and I can tell that if I do have a lot of leakage, I know where it came from. I know that these 2 back bedrooms, they were measuring 7 and 8 pascals. That's a significant pressure difference. So when I do my duct leakage, I'm like, oh, first place I want to go to are these 2 back bedrooms, because I know that my pressure pan indicated that they were the leakiest.
All right, I'm here with James Bowman from RectorSeal, and one of the new products that I like that RectorSeal makes is the Dissolve Kit. Dissolve without an E at the end. So you're making use of the dropping a vowel at the end in order to be along with the hip kids. So tell us a little bit about Dissolve, James.
Dissolve is a product that we developed specifically for mini splits. We developed Dissolve as the coil cleaner. It's a really an awesome coil cleaner. I mean, I like it. I've used it for other things. It does a great job of cleaning outdoor units and indoor units. It's safe for the plastics in the blower wheels, safe for the coil, safe for our pumps. It's odorless. That's another thing that I really, really like about this product is what we found during our testing we're developing it is that even a pleasant smelling citrus smell when you're in a 10 by 10 room can overpower you if you're trying to clean a unit. So odorless was important. And then from there, we went on to develop the cleaning kit. Uses a disposable bag. Some people say, well, can I reuse it? Well, yeah, you can reuse it if you want to, but if it rips the second or third time, it's on you. But also, we made it disposable because can you imagine you drain all of this nasty cleaner and dirty water and all the grud out of this thing, and then you're going to take it home, take it into your shower, clean it, then hang it up and dry it and fold it so that when you use it again next month, it doesn't look like something you dug up at the cemetery.
Right.
So throw it away. The bags are less than $10, replacement bags. The kit includes a gallon of our cleaner, the cleaning frame, 2 bags, a brush, and a nice bucket. The bucket has a gasketed ratcheting lid. That's another thing that's nice. If you're in somebody's nice home or office and you've got a couple gallons of nasty stuff along with everything else in this bucket, you can put the lid on it. It seals so you can carry it out of the space without worrying about leaking. If you have to carry it back to the shop, if it gets bumped over, it doesn't leak. So we even went as far as to make a good bucket for it. Really a thorough way for cleaning blower wheels and mini splits.
If you've ever had to clean a ductless fan coil, evaporator coil, blower wheel, you know how nasty it can be, and the Dissolve Kit from RectorSeal is a great product to help make that job easier. So now, what are some of the most common things that you are doing remedially? So if you have a contractor who says, not only am I going to test this so that I get my manual J straight, but I'm going to test it, and if I see a problem, then we're going to fix it. What do they fix generally?
The concern about fixing is twofold, and one of which is, do you have gas appliances, and where are the gas appliances? So we indirectly kind of ignore the stove as a general, but if you're doing combustion analysis, you need to make sure your stove isn't an issue. The tighter you make the home, the more these combustion risks happen in the house, and you become somebody who created something that was okay to have in the house or near the house to now you allowed a lot of carbon monoxide or other contaminants to get into the house or stay in the house. So even if the garage is where your hot water tank is, one of the things you can do with the blower door is determine how connected that area is with the blower door. You're going to isolate the connectivity. So before you do any of your air sealing or even sealing up your return leakage, that I need to make sure that my combustion appliances are working correctly. Seal the house. So normally it's a top plate issue for the attic. It's the most common places. Chases are the number one issue. They got a huge opening that allows you to look down inside the house. Fireplace chases, all this area, it's all around the fireplace where you can look down and see the actual drywall. That means that they are a major infiltration source. So all that needs to get sealed up. They're using some type of fire-rated material in the attic and a lot of spray foam to seal up the top plate. So that's number one. And then again, confirm that your combustion appliances are still drafting.
So this is the thing that everybody says. It's like the most commonly repeated phrase whenever you talk about sealing a building of any sort. People say, well, you can get a building too tight. So go ahead and address that.
Yeah, it depends on where you don't mind breathing your air from, because you're probably living in a house or maybe you're in your car doing this concept. When you get back to your house, evaluate where your air comes from. So you turn on your exhaust fan in your bathroom or wherever, even your kitchen, which is a very powerful fan, and air in equals air out. That's fundamental to trade school day one. So where is the air coming in from? I pause there, so I want people to visualize that it must be coming in from somewhere in your envelope, around the bottom plate, through the walls, around that receptacle, from the attic, from the crawl space. All those places are just nasty, nasty places. So that's where the air is coming from now, okay? So if I can reduce that, then I can make it tighter, but I now need to make sure that I'm having replacement air. I don't like the phrase fresh air because I don't know where it comes from. But I do need for the occupants to breathe more air. That's a commercial concept. So the residential is still trying to figure that out. So I need ventilation. So you must have good ventilation if you're going to seal the house up to another level, or just good ventilation, period. So I know where it comes from, and that is considered clean air, and it's controlled, and I can actually account for where it came from. It didn't just come through the wall in some random lack of area that just was the least resistance location.
Yeah, and at this point, we know that now ASHRAE and ASHRAE 62 is kind of telling us that now we need to think about outdoor air. We need to think about bringing in outdoor air even in residences. But in many cases, we're going to go to retrofit applications where there has been no consideration for outdoor air. And essentially what they're saying when they have no consideration for outdoor air is that, well, we know the building's leaking. And we're not worried about controlling it. It just is what it is. And so you just pick a leak tight, very tight, whatever it is, you just pick it off the list and you just go with it. Whereas now, if you are sealing a space and you're sealing it fairly hermetically tight, that's a good thing. And it's something that we do want to do because we don't want those undesigned paths. But we do need to create a designed path. And depending on your climate zone and the particular circumstances of the space, you need to be then adding in some outdoor air that's going to be treated in some way. It needs to go through a HRV or an ERV or a supplementary dehumidifier or something, as well as some filtration to ensure that that air is cleaner than what it was before in better condition.
This is the number one topic. In the 90s, we figured out and resolved insulation. And we're like, okay, we got that down. So now in the 2000s, we're starting to do, okay, codes more focused on air sealing and better HVAC. And now we're coming to the last stage, and that is that how do we do ventilation? So I do think that once we kind of get this last phase down, all of our homes will finally be the superior homes that they should have been for quite a long time. So for some reason, builders, HVAC contractors, everybody is just terrified of installing this replacement air. And I understand the concept, like, why should I seal something up and put a hole in it? But the reality is you're sealing up the environment to control that hole. So there's always a hole. It's not like you're denying there's ever been a hole. The reality is I just now know where that hole is and what it's doing, and I can turn it on or off as I need to, or make sure that it's filtered and control where it actually dumps this moisture. And that's actually the challenge. So Florida and the high moisture south climates are a significant challenge to do this. There is no ready-made solution. You really got to be on top of your game to do this. So there are some things that are out there from manufacturers, or you do need to be working well with a design that has dehumidification immediately. Otherwise, you're just dumping high moist air into a cold environment, and that doesn't do well in terms of creating some type of fungal growth. So your goal is to avoid that. Up north, it's less of a challenge because they have moisture issues, but nothing compared to what's down here. This is actually, I've been down here for the last many months doing code training, and I am aware of humidity. You guys are on another world with the amount of humidity you have to overcome down here.
Half of what I think about in day-to-day function of our business is moisture, is latent load. I mean, it's just a huge part of what we do. Even when you see what comes out of the ends of our drain lines compared to other places, it's just there's crazy stuff in our air and a lot of moisture, so that does make a particular consideration. But I think you're right in that just ignoring it and saying, well, the building's leaky, that doesn't help anybody. So that just adds insult to injury. But I do want to mention, because you kind of briefly brought this up about gas-fired appliances, is that you may have situations where systems were installed in buildings where they didn't have proper consideration for combustion air, for having appropriate combustion air, and now you seal it up and you don't have proper draft and you're not providing it with the necessary oxygen because you don't have designed combustion air, which is another side. I think there's a lot to be said for direct vent appliances when you are going to this strategy of sealing the space fairly hermetically.
Yeah, depending on where those appliances are, especially the older furnaces, but the hot water tank is still a natural draft appliance, and it's one of the most challenging ones, and it's very expensive to go to replace that with something that is direct draft. But it is the goal. If you really want to have a high-performing home, a better home, a healthier home is really the reality. It's what clients want. Don't assume that they won't be willing to pay for that. And you can show them why. Well, kind of go back briefly to the blower door, that you can actually make determinations on whether or not your attic or your garage is connected with the same concept of pressures that are similar while the blower door is on. So I can tell you if your garage had leakage, direct leakage to the garage, which means that you would have direct leakage from your combustion appliances. So all those things also backdraft. It takes less than 5 pascals, and most HVAC contractors live in inches of water in a column. So 249 pascals in 1 inch of water column. So that means it's a fraction of an inch of water column. And it just takes so little to backdraft that kind of appliance. And that can be done with supply leakage in your ducts. If you have excessive supply leakage, you can actually backdraft a hot water tank. So I mentioned earlier that you may go up and find that somebody had a major leak in their return system, all right? And once I go to seal that, then my supply leakage may be greater now in terms of being balanced, or what's now more dominant leakage. So if I correct my return leakage, now my supply leakage is actually greater, and it means it'll put a more negative draw on the house and on those combustion appliances. So duct leakage is a significant risk, and it's not always just sealing it up and realizing I've done a great service for my client. fine, but you need to be very concerned about where those combustion appliances are.
So yeah, pay attention to the largest duct in the home, in your structure, which is the envelope itself, and maybe start, what we're going to do is this winter, we're slow in the winter, so we're going to get a blower door and we're going to start experimenting with it on sales calls, just actually doing the blower door test, doing the pressure pan tests, and just seeing what we get. Again, the point is once you do this, you're going to start kind of going down this road and you're going to find that there's other things that sort of interconnect. But the goal here is to produce a situation where all of the air that we're bringing into the house is coming in through well-designed paths, it's being properly treated, and that we're consistently only putting the house under negative pressure whatsoever when we have no choice. Obviously, someone turns on a 400 CFM kitchen exhaust, it's going to be a little tricky to deal with that, but there are strategies that can be used. I mean, you can bring in the exact same amount of air that you're putting out if you design the system properly. And again, these aren't things that people are typically thinking about in residences, but they've been thinking about it in commercial applications all along because it really only makes sense.
One of the things that is hitting the ventilation and exhaust market right now is the ability to turn on your exhaust fan in your bathroom, even in your kitchen, and it actually triggers something that also then does a supply balance. So you can actually get balanced ventilation through some very minor upgrades or using some of your existing installs that you've already got. So there's a variety of new switches that are out there that actually can trigger the supply to open up and, again, make sure you're controlling your moisture load. But you can actually get a balanced ventilation without trying to install a new ERV or HRV. So there's a variety of stuff out there that Brian and I are going to try and tackle this fall and winter as to specific for the Florida requirements that are out there. And other people have these same kind of issues that they want to understand. So our goal is to be like, how can I install ventilation? And one of the things that Florida just stepped into is they just adopted a new code. And their new code is blower doors must be less than 7. A pretty easy number to hit. But if you're below 3, you now then need to install mechanical ventilation. And they were thinking that, hardly anybody will be that tight, but they're realizing that a lot of homes are below 3. And that means that I would find out within a matter of days as a contractor that they do the blower door and we're closing in less than a week. I need to go install mechanical ventilation and I have a week to do that. And that's not really a place you want to be in. So Be ahead of the curve if you're a contractor down here in Florida.
Yeah, when you're saying 3 and 7, you're talking about air changers per hour.
Yes, thank you.
Yeah.
That's right.
All right. Well, thank you so much, Joe. Appreciate your time, and I'm sure we'll be having a lot more of these conversations in the future. Oh, very quick, plug RetroTech a little bit.
So RetroTech is my main client, and if you're really looking for devices that you really want to have in your arsenal of great functioning and user-friendly gauges, you definitely want to go to RetroTech, and we also have a concept called RCloud, which automatically does your testing and logs all that data. So retrotech.com is the place to go. You will not be disappointed with that type of investment.
So it's retrotech.com, but it's not, the tech is spelled only with a C. So it's retrotech.com, because I made the mistake of going to actually spelling the word tech out. And then when you talk about misspelling of words, you can go to truetechtools.com, which is true spelled TRU, techtools.com, and you can find the entire suite of RetroTech products there. And as always, if you're interested in something, you can use the offer code GETSCHOOLED at checkout for an 8% discount. So thank you, Joe. I appreciate your time, and we'll talk again soon.
Thank you, Brian.
All right, so thanks for listening. Thanks a lot to Joe. I got to spend a little bit of time with Joe. He's a really great guy, very entertaining gentleman, very interesting dude, and I'm very thankful to him for stopping by the office and recording this. And I do think this is a piece of the industry that a lot of you would benefit from learning more about. So if you want to know more about all this kind of world, I would suggest going to the Building HVAC Science podcast, which is a member of Blue Collar Roots. Also, Zach Ciota from the HVAC Shop Talk podcast does a good job talking about airflow. He recently actually did a series on ductwork that he talked about on the tradesman. So it actually has a couple small clips on the tradesman, small little episodes where he talked about designing ductwork. So there's a lot of different podcasts in the Blue Collar Roots network, and you can find them all by going to bluecollarroots.com. I want to take a quick second and just thank Carrier. Carrier's been with me since I started my business back in 2005, and really my relationship with Carrier predates that. The main reason why I wanted to sell Carrier when I started my own business is that I had such a good relationship with their training staff. There's a guy by the name of Ray Johnson, and I used to go to his classes, and Ray was just a no-nonsense blue-collar guy, and he would just tell it like it was, and really smart, taught me a lot about air conditioning. And I like that about Carrier is that, yeah, they're a big corporation. Sure, they're a big business, but they seem to always care about their research development and technical side of their products. They advertise. Everybody advertises. I mean, heck, this is sort of an advertisement, I guess, but it's an advertisement that comes from a caring for the core functionality of the product. And I've always appreciated that about Carrier. Everybody has bumps along the road. Every business has things that don't go perfectly from time to time. But I'm still glad that I'm a Carrier dealer. I'm proud to be a Carrier dealer. We're doing really well selling Carrier equipment this year, and I'm really proud of how they handled the Greenspeed recall. They actually voluntarily came out and said, hey, look, nothing's happened yet, but we've noticed some things, so let's recall these boards and replace them. And I thought that was pretty good. It was a seamless process. They treated me well. They always have treated me well, even when I was a nobody. Even when I think my first year in business, I sold something like, $50,000 worth of units, which is well below what you should sell in order to deal Carrier equipment. But they worked with me, and I'm thankful to them for that. And I'm thankful that they're partnering with HVAC School to, once again, just invest in training of technicians. The same thing that brought me to Carrier in the first place and made me choose to use them is the same reason why they're partnering with us on HVAC School, and I certainly appreciate it. So what did the grape say when it was stepped on? Nothing. It just let out a little whine. We'll talk next time on HVAC School.
Thanks for listening to the HVAC School Podcast. You can find more great HVACR education material and subscribe to our short daily tech tips by going to hvacrschool.com. If you enjoy the podcast, would you mind hopping on iTunes or the podcast app and leave us a review? We would really appreciate it. See you next week on the HVAC School Podcast.